In this video, we demonstrate how to use our Vbox, the valve testing device for commissioning proportional, control, and servo valves. The test has three main objectives. First, we verify the correct wiring of the valve connector between the PLC and the control valve. Second, we test the function of the control valve with the hydraulic supply switched off. And third, we test the control valve with the hydraulic supply active, for example in combination with a cylinder. As a general rule, the connectors from the machine wiring must not be connected to the control valves before commissioning. This means that, before commissioning begins, all control valves must be disconnected from the machine. Why? If there is a wiring fault in the machine and the main switch is turned on, the valve electronics may be damaged. First, we identify the valve type. This ensures that the correct interface signals are selected on the Vbox. The type code is read directly from the control valve nameplate. In our example, we use a control valve with the type code shown. We then open the corresponding data sheet and identify the relevant signals. These mainly include the signal type for the setpoint signal and, if available, the feedback or actual value signal. In our example, we set the Vbox as follows: Operation mode, extern. With this setting, the setpoint signals from the control system are initially displayed on the Vbox. We set the display for the setpoint signal to volt. We set the display for the feedback signal to volt. If volt has been selected on the feedback signal display, the loop push button must generally not be pressed. The loop push button is pressed only if the feedback signal is set to milliamps and is not connected to the control system, meaning that the current loop is open. For more detailed information, please refer to our operating manual. We set the potentiometer to the center position, that is 0 volts or 12 milliamps. We also set the potentiometer selector switch to 0 volts or 12 milliamps. The enable function remains deactivated. Attention! The 24 volts to pin C enable switch must always remain deactivated for valves without an enable signal. Particular caution is required here. If the enable function is activated on a valve without an enable signal, the valve electronics may be damaged. In our example, the switch remains set to off because this valve does not have an external enable signal. The relevant data sheet indicates whether a valve has an enable signal. For demonstration purposes, here is the data sheet for a valve with an enable signal on pin C, and here is the data sheet for a valve without an enable signal on pin C. With the settings selected earlier, our Vbox is now prepared for the first test. We can now check the machine wiring. To do this, the correctly configured Vbox is initially connected only to the valve connection cable. This cable comes from the PLC or the machine control system. This allows us to check the power supply directly at the valve connection cable. Important, both power supply indicators must light up green. The correct polarity must also be observed. Incorrect polarity can cause malfunctions or damage the control valve electronics. In the next step, we check the interface between the control system and the control valve. To do this, the control engineer specifies a setpoint value via the PLC. This setpoint value is measured and displayed by the Vbox. In our example, a signal of plus 5 volts is output first, followed by a signal of minus 5 volts. If the setpoint value is displayed correctly on the Vbox, this means the control output for this control valve is operating correctly. The wiring for the setpoint signal and the supply voltage has therefore been checked. Please refer to our operating manual for instructions on how to check the feedback signal wiring. We now test the function of the control valve with the hydraulic supply switched off. To do this, we change the Vbox settings. The Vbox must now be switched to setpoint signal output. Here again, the settings must be selected in accordance with the information in the product data sheet. The Vbox is now no longer used to measure the control signal. Instead, it actively controls the control valve. This allows the valve to be tested independently of the machine control system. We make sure that the potentiometer is set to 0 volts and enable setpoint signal input via the potentiometer by setting the switch to pot. There are 3 options for supplying power to the Vbox and the control valve in this test setup. Option 1, power is supplied via the control system. Only the supply voltage is used. The setpoint signal from the control system is not passed on to the valve unless the operation mode is set to extern. Here too, we check both indicator lights before connecting the Vbox to the control valve. Option 2. Power is supplied by an external power supply unit connected to a 230-volt main socket. We connect the Vbox to supply it with power. As always, we check the indicator lights to verify the polarity before connecting the Vbox to the valve. Option 3. Power is supplied by a battery pack. The Vbox is secured in our battery pack. With the battery pack fully charged, the Vbox can be used independently of the main supply for up to 8 hours. We connect the Vbox to the battery, again paying attention to the polarity. We can then connect the Vbox to the control valve. We can now move the spool inside the control valve using the potentiometer. This test is carried out without a hydraulic supply and is only possible with directly operated control valves that have a feedback signal. According to the data sheet, we have selected plus or minus 10 volts for the setpoint signal and the feedback signal. We can now use the potentiometer to control and move the spool inside the valve in a targeted manner. The feedback signal tells us the position of the spool. Depending on the ambient noise level, the movement of the spool may also be audible. From a technical perspective, the Vbox sends a setpoint signal to the control valve. The valve is functioning correctly if the setpoint signal and the feedback signal approximately correspond. If the valve is not functioning properly, for example if the valve spool is stuck, the feedback signal will not change when the setpoint signal is varied. The setpoint signal changes in the upper display, while the lower feedback signal display remains static. In the final step, we test the control valve with the hydraulic supply active. First, the hydraulic pump is switched on and the procedure shown in the previous test is repeated. Make sure that the potentiometer is set to 0 volts at the start of the test. Initially, the potentiometer should be moved slowly. This allows the function to be checked in a controlled and safe manner. The valve actuates and the connected consumer, for example a hydraulic cylinder, moves. Depending on the machine setup, particular caution is required during this step because movement of the control valve may cause hazards from the hydraulic actuator. This applies in particular when larger deflections are commanded using the potentiometer. After the test has been completed successfully, the Vbox can be removed. After consulting the control engineer or electrician, we then connect the valve connection cable to the control valve. The control cable connected directly to the control valve indicates that commissioning has been completed successfully. The test is now complete. Further information and safety instructions can be found in our Vbox operation manual. The work steps shown in this video are intended solely as guidance. Always observe the technical data sheets and safety instructions provided by the valve manufacturers. Once again we point out that particular caution is required when the hydraulic supply is active. All tests are carried out at the user's own responsibility.